Okay, in this video, I will be going over all of your homework problems. Okay, starting for the very first ones here, you're asked to go through and find the vertical asymptote, and then after you have that vertical asymptote, you are asked to prove that you have a vertical asymptote using limits. So the first thing we need to do is start with our factoring, and notice we will have x minus 3 times x plus 6. That is all over x minus 3. Those x minus 3's will cancel, and so my function that's left is x plus 6. Now, as a side note, remember that you have a hole at where you went through and divided, so you've removed that, or you have a removable discontinuity. So now our function f of x is x plus 6, and we are looking for vertical asymptotes, which to find a vertical asymptote, that's going to be where you set the denominator equal to 0. Well, this one has no denominator to set equal to 0, so for number 1, there are no vertical asymptotes. Okay, so moving on to number 2. You will start the same way. You need to factor. So we have g of x is going to be x plus 4 over x plus 4 times x plus 5. And so again, we have a hole at x equals negative 4. Our remaining function, 1 over x plus 5. So for our vertical asymptote, you set the denominator equal to 0. So I'm going to take x plus 5, set that equal to 0, so x is negative 5. Now to prove this with limits, keep in mind that, and you don't have to know the graph of this, but I'm going to draw it just so that we see what's going on here, is that we have this vertical asymptote, and the graph of this should do something like this, and something like this on the other side. So what we're going to do is find the limit as x approaches negative 5 from the right of g of x, and then we will find the limit as x approaches 5 from the left of negative 5. So from the right of negative 5, we need to choose a number and plug in, and if we look up here at our function g of x, and I'm plugging in a number a little bit to the right of negative 5, then notice we will end up with a positive infinity. And then if we plug in values, and again set up our limit as x approaches 5 from the left of g of x, then we will be getting a negative infinity. So here with this, the only reason we're setting this part up is to prove x equals negative 5 is a vertical asymptote. And that's why we're setting that up. Okay, moving on to our next question. Again, same process. Some folks like to do the slide and divide method of factoring. So let's go ahead and factor x squared minus x minus 30. And so that's going to lead us to x minus 6 times x plus 5. We do need to come back and divide by our 2. And so that's going to factor into x minus 3 times 2x plus 5. And then our denominator is going to be here x minus 3 times x minus 2. The x minus 3's will cancel, so we see that h at x is going to be reduced down to 2x plus 5 over x minus 2. And then we have a vertical asymptote at x equals 2. That's going to be what makes the denominator 0. And then by the same process, we are going to go through and set up our limit as x approaches 2 from the right of our function 2x plus 5 over x minus 2. And then we'll also look at the limit as x approaches 2 from the left, 2x plus 5 over x minus 2. And choosing a value a little bit to the right of 2 and subbing in, that looks like that's going to give us positive infinity, and a little bit to the left is going to give us negative infinity. So therefore we have our vertical asymptote. Now number 4, we do need to remind ourselves that x squared plus 1, that is prime. It will not factor. Well, if I can spell prime correctly, that would be awesome. That is prime. So there's nothing to factor and cancel here, so I would set x plus 1 equal to 0, so x equals negative 1 is our vertical asymptote. And then we're going to talk about the limit as x approaches negative 1 from the right of our function f of x. And then we'll look at the limit as x approaches negative 1 from the left of f of x. And so now to choose a value a little bit to the right of negative 1, so maybe negative 0.9. If we plug in and square this, then of course that's going to be positive, and so I'm going to have a positive value here. So from the right, that's going to be positive infinity. And then from the left, let's see what we're going to end up with from that left side of negative 1. So we could do negative 1.1. Let's let x be that. So we're going to end up with a positive over a negative, so that's going to be negative infinity. All right, let's move on to some other problems. With number 5, again, a good way to approach number 5, since you have a polynomial here, you can divide this up into 3 different limits. So we could look at this as the limit as x approaches 0 of 4x plus the limit as x approaches 0 of 3 plus the limit as x approaches 0 of 1 over x squared. So we see from this first limit value, that's going to be 4 times 0, plus, this is a constant value, 3. What this implies is, if you just have a number here, it doesn't matter what x is approaching, your answer is just that constant value. Plus, now this is going to be where it gets a little bit messy over here. That's 1 over 0. Well, 1 over 0, that implies a vertical asymptote. So we have to see what's going on with this particular function on the left and right. So we will need to split off that limit and break it into 2 separate parts. So then I look at the limit as x approaches 0 from the left of 1 over x squared. And then I need to look at the limit as x approaches 0 from the right of 1 over x squared. So whenever I sub in, let's say a little bit to the left of 0, negative decimal, but that negative decimal is going to be squared, so that's going to become positive. So that's tending toward positive infinity, and the same is true for to the right. So notice what we have here. We have our first term is 0, plus 3, plus, and this we really shouldn't write that, but that is a way to think about it. So we are going to end up with infinity for an answer. Okay, well, let's look at number 6. We are approaching 0. So let's see, if we plug in 0, I'm going to have negative 2 over 0, which again is a vertical asymptote. So we need to divide up this limit as x approaches 0 from the left of x minus 2 over x squared. And we need to look at the limit as x approaches 0 from the right of x minus 2 over x squared. So a little bit to the left, well, the denominator is going to be positive because it's all squared. And then the top is going to be a negative minus 2, so that's negative. So this one's tending toward negative infinity. Here, a little bit to the right of 0, well, that one's kind of strange. Let's say 0.1. That's a little bit to the right. the denominator again is still positive, but the numerator is negative. So that's tending toward negative infinity as well. So notice from the left and from the right, we are tending toward the same value. So I have negative infinity. Okay, moving on here, let's look at number 7. And with number 7, whenever we plug in 0, sine of 0 is 0. So, again, we're going to end up in that situation where we have a number over 0. Again, vertical asymptote. Well, with this one, we would need to divide up our limit and look at as x approaches 0 from the left of 2 over sine x. And then we need to look at the limit as x approaches 0 from the right side. And here, this would be a non-calculator. We can do this without a calculator. What we need to do here is look at, from the left, we might not know exact values for sine as far as decimals, but I know that all trig functions are positive in the first, and sine for the second, tangent for the third, and cosine for the fourth. So a little bit to the left of 0, that's going to be down here, because right here is our 0 degrees, so that means we're down here in the fourth quadrant. So that's going to tend toward negative infinity, because sine is negative in that fourth quadrant. And for a little bit to the right of 0, it's going to be here, and we know sine is positive in the first quadrant. So notice we have one side is negative infinity, one side's positive infinity. So this limit does not exist. Right, moving on to number 8. Now on number 8, notice that we are just approaching from one side. So let's let x here, we need to sub in something just a little bit to the right of 5. So let x be 5.1. So when we do that, we have a positive on top. We have a positive for the first parentheses, and we have a negative for the second. So that's going to let me see that we are tending toward negative infinity. All right, looking at number 9, several people have asked me about this. Now, when we do our straight substitution here, when we plug straight in, then that's going to give me the natural log of 0, which does not exist. We're not going to have a value there. So we need to look at a value a little bit to the right of 3, so we can let x equal 3.1. Now when I do that and sub in, well, I know 3 squared is going to be 9, so this is really going to be the natural log of point something. It's going to be a decimal. And for a natural log of any decimal like this, that's always going to tend toward negative infinity. That's going to be a negative value. All right, so let's move on to our next problem, number 10. And again, we're approaching 3 from the left, but I think they were trying to be tricky here simply because we can plug in and get an answer here. Let's plug in 3. 3 squared is 9 over 3 squared again, 9 plus 9. So that's going to give me 9 over 18, which is just 1/2. So I think they were trying to be tricky on that one. Moving on. Let's look at number 11. And again, we're approaching from the left. Do sub in. And of course, this will stay 1 plus, but this right here, that's going to give me a number over 0. So we need to evaluate just this one side of 1 over x. So something a little bit to the left of 0, negative 0.1, well, that's going to give me negative infinity. And negative infinity plus 1 is still tending toward negative infinity. Okay, and then number 12, this has a lot of factoring involved in it. This is the difference of two squares. And again, this one was so much factoring like this. Let's go ahead and write it out and see what happens. This is going to be, to get x to the fourth, we need x squared and x squared. We don't have a middle term, so all of those canceled out, so we need a positive and a negative, and the only way to get 1 is just 1 and 1. Well, nothing will cancel just yet, but this will factor again. So I'm going to bring down the limit as x approaches -1 from the left of x plus 1 over x squared plus 1 times, and the same process again, and I'm going to get x plus 1 times x minus 1. We will cancel out the x plus 1s. Keep in mind you're dividing, so there's 1s left. And so now let's reevaluate our limit. Let's try to replug in -1. So when I do that, I have 1 on top. First parentheses, I'm going to get a 2 because -1 squared is +1. And then I'm going to plug in -1 here, and I'm going to get a -2. So I'm going to end up with -1/4. All right, so let's continue on. And number 13, we're approaching 0 from the left. And so from the left, we need to let x maybe equal -0.1. So let's see what happens with that one. We do need to substitute in. Of course, if I plug in 0, I get -2 over 0, so that can't happen. So if I let x be -0.1, I'm going to have 4e and then -2 over -0.1. So then if I do that, then that's really going to become 4e to the +2 over 0.1. So that's telling me this little thing is tending toward positive infinity, because this is going to be a positive value here. All right, looking at number 14, same idea. If I plug in 0, I'm going to get weird stuff here, because natural log of 0, that does not exist. So that's treated just the same as a vertical asymptote. And so we need to find a value a little bit to the right of 1. So I'm going to let x equal 0.1. And so whenever I start subbing in, I'm going to look at the natural, from the right, 0.1. So I'm going to have the natural log of 0.1 over 0.1 plus 3. And again, I'm going to have natural log of a decimal, and that's going to tend towards negative, and then the bottom's positive. So 14 looks like it's tending toward negative infinity. All right, moving on, number 15. Subbing in here, if we plug in 0, I'm going to get 2 to the 0 over 0, which is 1 over 0, which is a vertical asymptote again. So I need to look at a number to the left of 0, so let's do -0.1. And so when I plug in, I have 2 to the -0.1 over -0.1. Remember, negative exponents, that means the reciprocal. So I need to move that 2 to the denominator. So I'm going to have 1 over -0.1 times 2 to the +0.1 because I've done the reciprocal. And so notice that on this one we are tending toward 1 over something negative. So positive over negative, which is going to tend toward negative infinity. Right, number 16, more of the same. Number 16, we're tending from the positive one side. If we do our substitution, we are going to get e over 0. Again, vertical asymptote. We need to look at that limit as x approaches 1 from the right. So when we do that, let's let x be 1.1. So we're, again, just looking to see for positive or negative. Well, e raised to the 1.1, that is still positive. 1.1 is bigger than 1, so that's going to be positive. So this is tending toward positive infinity. All right, so for these next ones, we are going to talk about the limits at infinity, and we're going to relate that to horizontal asymptotes. So anytime we are talking about limits at infinity, we are looking for a power struggle. We're looking at what is going to have the most power on top. And I'm going to compare that to the most power on bottom. So I'm comparing that to 2x squared. So notice that these two things are the same. They're canceling each other out. So the answer to this limit is negative 5/2. So what that means is that I have a horizontal asymptote of y equals negative 5/2. Now the answer to the limit is just negative 5/2. The horizontal asymptote is y equals negative 5/2. So be careful with that. Okay, for number 18, again, same idea. We're going to look at what contains the most power on top. Look at what's containing the most power on bottom. So where's most of the power at? It's in the bottom. So that bottom is growing faster than the top. So when anytime that happens where the bottom has most of the power, then my answer is going to be 0. And we can say that we have a horizontal asymptote at y equals 0. Okay, moving on to the next. Again, we are going to be looking for a power struggle because we're at infinity. So here, the highest power that I see, or the biggest dominating power, is going to be that negative 2x cubed. That's going to be the dominating power on top. And then we're going to look for the dominating power on bottom, which is down here at x squared, 3x squared. And so look at what we have the most dominating power at. We're looking at the top. That's where most of the power is going to be. So here, that's the power. So notice that it's more on top than it is bottom. So that is going to tend toward unbounded. So this is going to tend toward infinity here. It's growing without bound. All right. So, and really, hang on. I think that would be tending toward negative infinity. All right. So let's look at number 20. With number 20, with the square root, we don't want to rationalize a bunch of this, so we're not going to. I'm going to do some algebra magic to that bottom portion. So I have the square root, and I'm going to factor out x squared. So I'm going to have 1 minus 2 over, let's see if I factor that out, then I'm going to have 1 over x cubed, no, just x, there we go. All right, and so as I approach negative infinity, this will go out to 0, and the square root of x squared is just x. Now that method usually confuses the snot out of people, so what I'm going to do is, again, let's focus on power. So that's going to be 3x over, I don't really care about this business here, it's not dominating anything, but the square root of x squared, that's dominating stuff. So what I'm going to do is just focus on this portion, which should reduce down to be 3x over x, which is just going to give me 3. And if we look at here, this is balanced. Look at which way we are tending toward. We're tending toward negative infinity. So here, that is going to be negative 3. And I forgot to go back. Let's see. I need to talk about the horizontal asymptote on 19. I forgot. So the horizontal asymptote on 19, since we hit negative infinity, that asymptote is not going to exist. So here, the horizontal asymptote does not exist. So we'll probably have some kind of slant asymptote for this. Right, and then in number 20, the same idea here. So we're going to end up with a horizontal asymptote at y equals -3. All right, so moving on, let's look at 21. Same idea again. So with 21, we're going to have here the dominating power on top is x squared. Dominating power on bottom is going to be the square root of 2x squared. We are tending toward infinity, so really I'm going to have x squared over x root 2. And notice where most of the power is. That power is going to be sitting up top. That's where most of the power is contained, so this is going to tend toward infinity. And so here there's no horizontal asymptote. For number 22, I'm going to go through the same process again. We're going to have our most power on top. There's 2x. On the bottom, I'm not going to really care about that plus 3. It's not going to make a difference out towards infinity. I need to look at the square root of 4x squared. So I have 2x over, well, that's going to give me 2x as well. So look at where our power looks like it's going to be balanced. And notice that we're tending toward negative infinity. So we're going to have negative infinity. Or negative 1. That reduced down to negative 1. Sorry, guys. So we end up with a horizontal asymptote at y equals -1. All right, last set of problems here. And again, we are still trying to work with limits at infinity. So as x approaches positive infinity, notice we have 5 times 1 minus, that's e to the negative x, which is really 1 over e to the positive x. Negative exponents mean reciprocal. So notice that I'm subbing in infinity. So e to the infinity, that's a huge number. And then 1 divided by that, that's going to tend towards 0. So this limit value is just going to be 5. Right, and then number 24. Oh, they were trying to be tricky on 24. The highest power I see on top for 24 is going to be x to the 4/3. And then on bottom, I'm just going to square this term here. So that's going to give me 16. And exponent raised to an exponent you would multiply. So 16 to the 4/3. And so it looks like here our power struggle is balanced. So I'm going to have 1 over 16. So the horizontal asymptote is going to be y equals 1 over 16.